Okay, in example 2.6, we want to find the marginal revenue at x equals 50 when the revenue is given by the function r of x equals 1 over 1,000 x cubed plus 10x. Now, to find the marginal revenue, what you need to do is you need to find the derivative dr dx, which we've defined to be the limit as delta x goes to 0 of r of x plus delta x minus r of x all over delta x. And I'll teach you an algebraic way of doing this in the next section. So rather than go through this whole calculation, I'm just going to use a quick shorthand. I know that this derivative is going to be 3 over 1,000 x squared plus 10. Okay, so that's the derivative of the revenue function. And now to find the marginal revenue, we know that the marginal revenue is actually equal to the derivative evaluated at that point. So to get the marginal revenue evaluated at 50, all you do is you take 3 over 1,000 multiplied by 50 squared and add 10. Okay. And that's going to give you 17.50. So that says that you're going to make another, that's estimating that we're going to make another $17.50 by selling one more unit if you've already sold 50. And then it says to compare this change in revenue to the actual change in revenue from selling 50 to 51. So we can calculate R of 51. That's going to be 1 over 1,000. 51 cubed plus 10 times 51, and we can calculate R of 50. That should be 1 over 1,000. 50 cubed plus 10 times 50. Let me just plug these into a calculator. We got 625 for R of 50. And when I plug in 51, I get 642.51. Oh, sorry, 0.651. So you can see that the actual difference would be R of 51 minus R of 50 equals what is that? 17.651. So you can see that the marginal revenue estimate using the derivative is 17.5. The actual difference is 17.651, and the marginal revenue calculation is just a little bit simpler. So a lot of times we just use this as our approximation.